Hi guys. I'll be speaking in English since I understood that some people here are English speakers. My talk is called Code Archeology 101. So I know you probably came to a React Meetup to hear about the greatest and the latest, but we can't avoid that a lot of our job, a lot of our day-to-day job is not done on some GitHub project where we can select the libraries, we can select the latest frameworks, and we can play with it. A little bit about myself. I'm Liad Yosef. I'm the client architect in Duda for several years now. I'm in charge of the entire front-end operation in Duda. And Duda, as Adi mentioned, we're a web design platform for pros, so we have a platform for website building. We approach businesses, we're B2B, we approach companies that build websites for others. Our application is very UI heavy. A lot of client is involved, and since we exist around 8 or 9 years, there is a lot of baggage in our code base. So let's start. I'm sure every one of you know and love JavaScript Weekly, right? If you haven't read it or haven't subscribed to it, it's a weekly newsletter. It comes every Friday, filled with the best and the latest and the greatest that JavaScript has to offer. The only problem with this is that it's weekly. So we have another one the week after, and another one the week after. And if we're tired of JavaScript, we have the front-end focus, and we have code drops, and CSS Weekly, and Web Tools Weekly. And all of them have the best content in them. They have the best frameworks, and they have the best libraries. And with all this richness in the JavaScript world, it's not surprising that people started to feel the JavaScript fatigue a couple of years ago. You just didn't know what to choose, right? Because everything was good, everything was the best, everything is what you wanted. When people start to post how I stopped worrying and learned to love the JavaScript ecosystem, what is the JavaScript ecosystem? I mean, 10 years ago we knew jQuery and that's it, and now we have this entire ecosystem. The main part where we see it is in large code bases. Our large code bases, they evolve over time. This is okay. Code bases should evolve. The problem is they do it on their own, because every new library, every new framework, everything that we read about, people try to put in our code bases. So it's not surprising that when a new developer comes to our company and he takes a look at our code and he's like, okay, I don't really know what it means. I don't really know why everything is there. What's the import from underscore? What's this decorator? Why is the code structured like that? It's not how I read. It's not how the boilerplate are built, and it basically it looks like, I don't know, ancient Egyptian or something like that. So you can hear the most common question, and by the way, the most common GIFs in tech talks is why? Why do you do it? Why did you put all this technology? Why did you put all this infrastructure? So follow me in the journey of Indiana Jones and the mystery of code bases. When preparing this talk, I thought that I'm going to talk about actual code archaeology, i.e. how to handle connections between React and legacy JavaScript and everything. But this talk is about something a little bit deeper. I'm going to tell you about the process that we did migrating from vanilla or legacy code base into React, but it doesn't have to be specifically React, and what we learned and what are the philosophies behind such a migration. So the first stage, understand your prehistory. When you come to a code base, just try to understand what's there. This is our product 5 years ago. This is our what we called the old editor. Of course, back then it was called the new enhanced editor. Now it's the old editor. And it's pretty basic. I mean, it's pretty decent. You can do all sorts of stuff with it. The code base that supports it is chaos. It's really chaos. And let's take a look at some of the elements in that code base, okay? So obviously we use a lot of jQuery. What you see here is jQuery code and some more jQuery code. And that's a proper sound effect. And some more jQuery code. It can't even scroll since it's too big. And all of this code, all it does is open this pop-up because it's jQuery, right? So I think we can safely take this code and refer it as the first element in our code base, which is the jQuery dinosaur. If you look at our code base, you would see some Ember code. Now, Ember is okay, but the problem is that we had one developer that was really proficient on Ember, and he decided to change a lot of the code base to Ember, and then he left. So no one knows how to maintain this thing. So in our code base, we also have the Ember memo. Take another look at our code base. We have a lot of files, I don't know if you can read it, that have whatever you do, don't remove. I don't know why it's here, but it works. And the code base just grows and grows and grows, and there are files that we don't know what they're doing, but we don't want to touch them. So we just add to the code base, thus creating white elephants, or in our case, just white mammoths, right? White mammoths and what is called cold fossils that no one can remove or touch. Let's talk about the client architecture that we had. None. We had a single JSP file called the shell JSP that was sent from the server to the client, bringing with it our entire DOM and a list of JavaScript files, right? And the order was very important because everyone is dependent on another, and they communicated through the global object. So the JavaScript file communicated between themselves, and they also changed the DOM and listened to events from the DOM. So we can take all this thing and create the flying spaghetti monster. That's our code base right now. Sorry, 5 years ago. That's our code base when we were looking at it 5 years ago. So this was our prehistory, and I want to advance to the next stage, which is free evolution versus intelligent design. Why do I ask that? Because who can tell me what is wrong in this code base? I'll save you the trouble. The answer might surprise you. It's nothing. Nothing is wrong in that kind of a code base. Why? Because you need to understand the problems before you start thinking of a solution. You can't fix code unless you know what are the problems in that code. So in our case, none of the code was testable. Fixed bugs caused side effects. Every time we fixed a bug, we created 5 new ones. Our code base became read-only code base. You can just add to it. No UI consistency whatsoever, because every JavaScript file, every jQuery file just changed the DOM however it wanted. And our product could not advance. We could not iterate quickly enough the way we wanted. So we sat and we thought, okay, what we're going to do? And the first thing that we thought is total annihilation. Let's just destroy, rewrite everything, right? That's the most, I mean, that's the purest thought. So let's just destroy everything, have a green field, write everything from scratch, and that's wrong. Because on the other side of the problems, you have the requirements. And you have to understand the requirements before you migrate. The requirements come from 2 places which are the most important place in every company. First is the business, because no one cares about code. No one cares about code. No one buys code. They buy the product. So the business, the sales, the marketing, everything that is related to product is really important. And the second, maybe more important thing, is the developers. So if the businesses have problem and the developers have problem, you have a problem, and you need to understand what's bugging them. In our case, it was bring back the confidence in the system. So find a better way to write code which is scalable, testable, quickly, because we need to ship quickly, for server developers, because in that time we had a lot of server developers in our company, on a running platform with users and no tests. And our reaction was, sure, yes, let's do that. I just leave this GIF because it's so cute. But once you decide you want to migrate, you need to understand what features you want in the new product. And in our case, our product dictated we need feature parity. We need the new product to have the same features as the old product, meaning taking this editor and turning it to this editor. And basically, it's like that, right? It's trying to replace a wheel on a moving car. So we couldn't use the wipeout approach. Basically, the wipeout approach, meaning, okay, you have a new product, you develop it while your old product is still in production, and only when the new product is ready, only then you replace it. We couldn't use that approach because our product is so big that we had to release chunks of it, new parts of it to the users just to understand if it's going to work in production. So instead, we went for something that's called a strangler pattern. And despite the intimidating name, it's really simple pattern. It means, okay, I have an old product in my head. Let's write new features within this product and let these features grow, and eventually consume the old code base, hopefully. So in our case, it was take the editor and just try to replace bits and bits and bits in it, okay, until it's migrated. You have to prioritize what you want to migrate, since you have the UI, the UI logic, the business logic. In our case, we decided not to migrate the business logic. It was really complex, and focus only on migrating the UI and the UI logic. Okay, our next stage is to gather the framework, to gather our tools. You have to choose your tools really carefully, because remember, you have the hype. You have to be aware of the hype. In our time, when we tried to decide, it was like the peak of the JavaScript fatigue. Everything was on the table. Everything was possible. And you have to remember that technology is not the goal, right? Because no one will buy your code. You need the code to build to last. And if you're writing something new, you have to make sure that the code that you're using will allow people to, after that, build something on it. So you have to pick the right one for your requirements. That's really important to remember. There is no right choice. There is a right for your requirements. For example, our requirements were that we need to replace small parts of the code. We need to do it quickly. We couldn't use a framework. We had to use library. So following our requirement, drum roll, which selected React, which is very surprising considering this is a React meetup. So we selected React. The first thing we did, okay, how to migrate to React. You search Google, then you find the article, migrating your frontend to React step by step. Great, we're done, right? And then you understand that all of the articles are how to migrate a simple accordion plugin, simple accordion component, and after that it just, okay, then take it from here, which is basically how to draw an all, just draw the two circles, and then draw the rest of the arrow, right? So in order to try it out first, we decided to take one feature, try to implement it with React. In our case, it was this stripe pop-up. And this gave us the chance to a little bit experiment with React and JS6 to see how do you write it, to introduce Webpack and Babel and compile steps. And we learned to work with external nodes, meaning that we have our legacy code, and now our legacy code need to call another code just to render the DOM. So we managed to change like all of this to just this. And if we take this spaghetti soup that we saw earlier, the transition was really nice. So now the legacy code talks to what we call the modules manager, and the modules manager can initialize whatever component it wants. What about state management? Not now. Not now. We decided not to handle it, and that's another important principle. Don't try to handle more than you need. Don't try to bite more than you can chew. Okay, we didn't need state management at first. It was the magnificent year where both Dan Abramov and Michelle W. Introduced Redux and Mobix, and we just decided to stay out for a second. Okay, the next phase is to talk about modularity and abstraction. When you migrate a large code base, and you know that you're addressing developers, you have to think ahead. What we see in the picture here is Barcelona. From this height, it looks a little bit chaotic, right? I mean, it's nice. You have the Sagrada Familia in the background, but it looks a little bit chaotic. When you go a little bit higher, you can see the pattern in the city. Now, the city planners didn't know that it's going to grow that big when they planned it, I don't know, hundreds of years ago. But they had the foresight to plan it in a way that when it scales, it will scale in a good way. It will scale in a good way. So we call ourselves architects and engineers. Architects and engineers build things that last for decades, centuries, even a millennia. We have to adopt the mindset of town planners when we think about migration. We have to remember that the software evolves quickly. So we need to build to last, we need to build to scale, and we need to build to be replaced, which is really important. We decided to make our interfaces framework agnostic just because of those reasons. So we took the modules, and we call modules parts of the UI, parts of the product, which are separate from each other. So we took the modules that we wanted to migrate, and we put a layer of API in front of them. It's a really thin API that doesn't care how the module renders what it renders. It's just a facade, just the interface between our old code and the module. Each module has different apps within it, and we call apps just parts of the UI part. But again, those apps have simple loader within them, which is just an interface that has init and close. That's it. The module doesn't know if the app is React, Ember, Vanilla, Web Component, doesn't care. The legacy code doesn't care. And that gives us modularity and abstraction. So basically, our code is just, we call the module manager, we get the module that we want, and we just take an app and say init. And every app requires different configuration, but it's a framework agnostic. And that's really important, because if you don't want to create the same situation that you came from, you have to make your code modular, and you have to make your code flexible. And that's a way to do that. So the next stage is common language. And when we say common language, we have several things in mind. So when you migrate, you have to build your component library early, and you have to build it well. Now, the reason that I'm saying it here is that during this crazy migration project that we did, it took us about 8 months to migrate, we decided that since day one, we put a dedicated developer and a dedicated designer, and whoever of you is working in companies that are less than, I don't know, 50 people, they know what it means, a dedicated developer and a dedicated designer. It's a lot, it's a big percentage of your workforce, just to make sure that our component library is written well, is designed well, is scalable, is generic enough, and that's really important. That's really important because you don't want to create this mess that you came from. So we decided to divide our components. Again, that's our decision. Your mileage may vary according to your requirements. We decided to divide our components to core components, which are just the core that we, that's the basic leaves, the basic nodes, layout, which organize the components within some sort of layout, and fields. But then we had another idea, and we said, okay, we put all these components in like a common module. We wanted to keep the flexibility and modularization of our entire code base. So we created a Webpack alias _, which means, okay, this is our common modules component. Using this alias, every component in our system can import core components from the core repository without caring where it is, without caring where the file itself is. So I can take this file, which imports flex and image from the core component, just put it anywhere else, and it will still approach the common module. And it's not just a trick; it's a mindset because it's easy. And if you're using Webpack, I strongly recommend you to explore its aliases. It makes the development easier. It makes the code more easier to reason about. So this is pretty much our architecture. We have a Webpack which goes to modules. Each module has React apps. The apps has its own components. But then we ran into a slight problem. We have the apps and the modules. They needed to access the business logic that we didn't migrate. So we need to make this happen. Why is it a problem? Because we wanted to keep our new code isolated. We wanted to be able to iterate on it quickly. And for us, accessing the code, it required us to have our server, the server that serves the JSP, to be up in order to read all the data that we need. We needed the site inside our site builder to be present. And that was a problem for our test and prototyping. Again, Webpack aliases came to the rescue, and we use Duda services as an alias within our code, an alias to our legacy code. Now, the reason that we do it is because we have a Webpack rule that says if we wanted to use mocks, these Duda services will go to mocks. Otherwise, it will go to the actual legacy code. And that's very important. That's very important for the developers. You can see how it looks here, but schematically, it looks like this. So the services, they go to this facade, which is Duda services, and in production, it goes to what we call native services and the legacy code. And in test time, it goes to the mock services, and the code itself doesn't know about it. And that's another important principle. Try to make your developers think just about the business logic, about what they code. Don't increase the cognitive load by introducing new things. So this kind of trick just allows the developer to just write and call services, and they don't care if you're in production or test mode, and it works. So eventually, our application, which now looks something like that, is actually pretty nice because we have the legacy JSP, which renders a React component, which, by the way, in this case, renders a legacy code. So we have legacy that renders React, that renders legacy code. And in another example, we have the React component rendering Ember code. So by keeping this abstraction and modularity, a React component can not only be rendered wherever you want, they can also render empty containers so that legacy code can be rendered inside. And that is very important. Just remember that when you do it, you need to manage your depth, because it's really easy to say, okay, I'm migrating all of my UI. I'm forgetting about the business logic because I have this facade that separates me. But you have depth. You have to continue migrating and migrating by your prioritization. Another important point, and I think the next step after you migrate an application, is called the path of least resistance. And you have to remember that your customers are the developers. Your customers are yourself and your colleagues, and whoever is going to maintain and work on this infrastructure in the future. And developers are people, and people will always choose the path of least resistance. It means that you can build the most amazing infrastructure. You can build the most amazing file structure that you can think of. But if it's not easy to work in, if it's not easy to develop in, if it's not helping the developers, they will find a way around it. And you can try to avoid some of it, but eventually it will turn a white elephant like we saw in the beginning. So since we're building for people, we need to remember that improving developer experience is the single most important result we can achieve. It maps directly to all of the requirements, to all of the goals that we want to accomplish. This cute building is a hotel building in North Korea. It's being built for 30 years now, and no one stays in it. No one stays in it, and no one knows why, but it just stays there. And our architecture should not get in the way. What does it mean practically? It means that when you choose your set of tools, you need to know who are you building it for. If you have Angular developers in your team, they would probably feel more comfortable with Vue. If you have RxJS developers in your team, they might feel more comfortable with Mobix. Java, which are maybe used to compiling or used to some of the ES6 features, might feel more comfortable with that. But you have to remember that when you introduce new technologies, especially if you're migrating to React from vanilla code, everything seems unfamiliar. All of a sudden you have a build step, and you have this weird HTML inside your JavaScript, and you have to take a lot, you have to think about a lot just to start writing. So our architecture, good architecture, should reduce the cognitive load. We should make sure that whatever we choose, whatever we do, we allow the developer just start writing out of the bat. Here are some of the stuff that we use in Duda just to reduce cognitive load. Again, that's our selection, knowing the places that we came from, knowing the developers that we had in the company. So one of them is CSS Modules. So a little bit like a small primer on CSS Modules. If you're not familiar with it, it's a really nice library. It allows you to write CSS in a separate file, then require it from the JSX, from your component, and it handles on its own the changing the class names, so the class name will be unique across the system. Now, I know what most of you are thinking. What about style components? What about CSS in JS? What about all of those other stuff? And those can be good. They can be right. I'm right. You're right. Every one of us is right according to what we need, because we had a lot of developers that had a lot of experience writing CSS. And we didn't want to introduce now CSS in JS, which is a little bit different from CSS. So we decided to go with CSS modules. Again, our choice. We're heavily using decorators. A decorator is a way to share behavior between components. It's really nice. If, for example, you want the components to there's a problem that probably saw in React. If you try to set state on an unmounted component, it throws an error, right? Because the component is unmounted. So you can do a little bit of workaround, and if when the component is mounted, keep its state as mounted, keep it like a flag of the component is mounted, and when it's unmounted, remove the flag. And then you can introduce a set state safe. We just check the flag and say if it's mounted or not. And in our case, we had it in a lot of components, and we decided to use a decorator that's called safe state. I mean, we wrote the decorator. It's just a function that gets a component and returns a component. It's called safe state. And then you can just decorate a class in React, and it gets this functionality. We're also using the Strudel component decorator that we wrote, and it gives a lot of common functionality between others, utilizing the CSS modules that we saw before. And again, why did we do that? I mean, you have high-order components, you have a lot of solutions, but our developers came from Java, and they were used to decorators. And decorator is a little bit cleaner than just returning a function that gets a component and then doing something. So we decided to go with decorators, again, just to reduce cognitive load. The last thing that we did, not the last thing, but the last thing I want to talk about is something that's called import barrels. So instead of numerous imports in a file, there is just one re-export file that you can import from. For example, if you have a file that's importing a lot of components from our component library, so instead of writing all of those import statements, we put single index file in our component library, and our file can just import like that. So it goes to _/core, and it imports automatically from index, and then you can just have named imports inside your code. Why did we do it? Convenience. Again, we were introducing a lot of new things, and our components were really complex, and we didn't want people to try to waste time in writing all of those imports. We had components that had 30 components within them, and this was our selection. So you need to remember that when you're building the foundation, just notice things that bug you, because they will bug everyone. So if you're having trouble with something and you try to fix it for everyone. So just leave, it's the Boy Scout rule, just leave the place cleaner than you found it. And again, your mileage may vary. The next level that we're going to talk about is performance. And there's a reason that I'm talking about it only now, because this sentence can be read in two ways. Tackle performance issues before they start, and tackle performance issues just before they start. And the truth is somewhere in the middle. You don't want to wait for the fire in order to put it out, but you don't want to pre-optimize. You can't think ahead about all the things that can hurt the performance of your build, hurt the performance of your UI. You just can't do that. Kitze in React Amsterdam this year, he had a great talk, and one of the issues that he talked about is that someone wanted to build a form, and he asked his friend how to build it, and his friend said, just use Redux Saga. And if you know Redux, you know that Redux Saga and just are don't belong in the same sentence. That's what happens when you try to solve issues before you actually know what you're trying to solve. In our case, we had an issue with the bundle size. So when we created our first module, it was okay, and then we created several other modules, and we discovered that no matter how small module we created, how small the module was, it was huge in size. And the blame was, as you can probably guess, that if you take this simple import statement, and this import statement brings the index file of the component library, it brings its entire component library with it. So Webpack sees it and just wraps everything together. So even if a module just required image from our core components, it got everything wrapped together. Who would have thought that our brilliant solution of import barrel wasn't a good idea? So we didn't want to give up. We didn't want to give up about the developer experience of just importing everything in a single line, and the answer was in a very unexpected place, Babel. So we're using Babel to transpile our code, and Babel, just a quick primer on Babel, it takes a source code and it knows how to convert it to target code using abstract syntax tree, AST. It's really interesting, you can read about it, but the thing is, Babel can also transform the AST to do whatever it wants with it. And for us it was good, because we had this problem, right? We had a code that we wanted to change it to something else, so we wrote a simple plugin that's called the import Babel plugin, the import barrels plugin. And this plugin is really simple in its concept. Before compiling, before Webpack runs, it just goes on all of the barrel files, saves it in a map, and when Webpack compiles, it takes this statement and reading from the map just breaks it to separate statements. So in this case, if we have two files that's importing from core, it will just break it to those statements. And it was okay. I mean, it works. I mean, it solved our performance issue. It solves our developer experience that we didn't want to give up. And that taught us that automation is the key. You have to automate everything in order to reduce the cognitive load from the developers. So we use Babel for developer experience, DX, developer experience and convenience. We use ESLint for conventions, which is really important. And we heavily use NPM scripts to use startup. This is part of our package JSON, and that seems complicated under the hood, but our developers can just write npm run start, and everything works. Everything just works as they expect it to work, which is great. So yeah, automation is the way to go. The last one is democracy. So why is it that important? Because we just went through an entire process of taking legacy spaghetti code base and trying to break it and trying to create the best infrastructure and the best architecture. But even with the best planning, it's really easy to slide back to chaos. Why is it easy? Because when you started to work on the project, there were probably 2 of you or 3 of you that sat and planned, or maybe 1 of you that sat and planned and say, okay, we're going to use React and we're going to use this and we're going to use it, and that's how we're going to write the code, and we're going to use decorators. And then you build it and you build it and you build it and you give it to the developers, and the developers just develop over it, but they don't really understand what happens underneath. So you need to remember, don't build a monument for your knowledge. It's not important if you build like the most amazing architecture, most amazing infrastructure. The pyramids are amazing. They're an amazing feat of architecture. But today, they don't really blend with their surroundings. So they're really pretty to look at, but no one would go to live in them, right? So you need to democratize the infrastructure. You need as soon as possible to hear opinions and spread the knowledge everywhere. That way you can avoid the Ember situation that I mentioned earlier, which we call OCK, only Carl knows, like those pieces of code that if Carl is on vacation, or Carl is sick, or I don't know, Carl just left, no one knows how to handle it. You don't want to become what you're trying to avoid. The other thing is to listen to weekend ideas, the ideas of strong developers that were in your team, and if you have a strong infrastructure, you will have strong developers that come back from the weekend and say, oh, we have to use the Mobix, and we have to use GraphQL, and Next.js is amazing. We have to go to this meetup and hear about it. Just listen to those ideas. Don't act only as the gatekeeper, but also as the integrator. And that's really important because your architecture is a living thing. We didn't migrate everything. We can't migrate everything. And by the time we migrated, new standards and new guidelines emerge. Make sure not to turn it into your own headache, but to spread the knowledge around. So you won't see yourself tweeting this like Dan Abramov after getting a lot of hits and a lot of feedback on Redux. Just we never create anything. So create. Okay, the future for us, for Duda, we just went through what we did migrating from legacy code base to React. But the future is that we're moving forward, moving to microservices and micro frontends. And the thing that allows us to move quickly, the thing that allows us to change to micro frontends, by the way, we can see here our first microservice in production, which is our comment service. It comes on top of the editor, and it has a different build, a different pipeline. It's stored in a different location, and just communicates with our editor. And the reason that we're able to do that is because of our infrastructure. It's because of our architecture. It's because we built it to last, because we built it scalable, because we built it to be replaced. So that's the direction that we're going to. We're going to utilize the infrastructure and to adopt new technologies, server-side rendering, for example. And the main takeaway from it is that when you look at the code and you think to yourself, what happened here? Just remember that this code is built with layers, and you can look at it as geological, archeological layers of decisions that were taken, and tools that were incorporated and maybe forgotten, and things that were made to help you work better. And it's like looking at like looking at layers on a mountain. You can analyze it like that. Is that the end of the road? I don't know. The Sagrada Familia that I mentioned earlier is being built for 150 years, and it's still considered a miracle. And you need to remember that every architecture will eventually become archaeology, even yours. I mean, we're writing today tomorrow's legacy code. That's what we're doing, because every legacy code, every crap code that we read, someone wrote it, and at that time that was a good idea. So in order not to become the villain, in order not to become the thing that we try to protect from, we have to remember those principles. We have to remember that when we build something, we need to build it to last. Thank you.